Every order you see here started as a plain text file sitting in a directory on disk. Let's trace exactly how it got here, from a raw fix message to a fully validated, uniquely identified order event, published and ready for pre-trade risk checks. FIX, Financial Information Exchange, is the messaging standard that connects every major broker, exchange, and algorithmic trading desk on the planet. It has been in production since 1992. The format is a sequence of tag equals value pairs, separated by a delimiter. Tag 35 is the message type. D means new order single. Tag 55 is the instrument symbol. Tag 54 is the direction, 1 for buy, 2 for sell. Tag 44 is the limit price. Tag 38 is the order quantity. The fix handler is intentionally minimal. Its only job is to turn a raw string into a Python dictionary. It splits the line on the pipe delimiter, then splits each field on the equals sign, with a max split of 1, so any value that happens to contain an equals character is parsed correctly. What you get back is a plain dictionary. Tag 35 maps to D. Tag 55 maps to UUID, and so on. The helper method isNewOrder checks tag 35 for the value D. That single check is all it takes to identify a new order single in the FIX protocol. The file processor is the entry point for the file drop path. It opens the file, iterates every line, and routes on message type. Logon and heartbeat messages are protocol control frames. They update session state and move on. A Type D new order is where the real work happens. The processor translates fix tags into named fields. Tag 55 becomes symbol. Tag 54 becomes the string buy or sell. Tag 44 is cast to a float price. Tag 38 to an integer quantity. Tag 49, the sender comp ID, becomes the client identifier. That dictionary is then published directly to the raw_orders Kafka topic. The file is moved to the processed directory once complete. Here is what lands in the raw ORIs topic. Clean JSON, one event per order line. No fix tags, no delimiters, just named fields. But notice what is missing. There is no order ID yet. This message came in from an external client. The order identity is assigned downstream. That is intentional. What happens to a malformed line? It does not silently vanish. The raw text and the exception message are published to the dead letter or order topics, a quarantine queue. The parse error counter increments in Prometheus. Critically, the loop continues. One bad line in a file of 100 orders does not abort the other 99. Only if the entire file is unreadable does it move to the rejected directory. Nothing in FIXFlux is silently lost. Here is a dead letter record. The original raw line is preserved exactly as received. The source file name is attached, and the error message explains precisely why it failed validation. This gives an operations team everything they need to replay or investigate the message without touching the live pipeline. The order service is a separate Docker container subscribed to raw orders. As each message arrives, the first thing that happens is deserialization into a typed Pydantic model, raw order event. If the field types do not match, Pydantic raises immediately and the message is rejected without touching any downstream system. If the model validates, the event moves through two stages, a business validator and a transformer. These are kept separate by design. Validation checks the rules, transformation builds the new shape. The validator enforces three domain rules. Price must be strictly positive, quantity must be strictly positive, and side must be either buy or sell. These are business constraints that go beyond type checking. A price of 0 is valid JSON, but invalid for a financial order. If any check fails, a validators is raised, the message goes to the rejected counter, and the pipeline stops here for this order. If everything passes, the transformer takes over. Its single most important line is this one. Order ID equals string of UUID 4. This is where the order receives its permanent identity, a universally unique identifier that will follow it through every downstream service, from risk checks to matching to the trade audit trail. Switching to Grafana, every step we just traced is instrumented. The Fix Messages panel breaks down throughput by message type. Logon, heartbeat, and new order each get their own label. The Orders Processed panel splits on outcome. Approved orders move forward. Rejected orders are counted but do not propagate. This is the live health signal for the gateway. If the approved rate drops while the Fix message rate holds steady, something changed in the validation or transformer stage, and you can see it here in real time. Five hops: a text file, a fix parser, a Kafka topic, a validator, a transformer, and a second Kafka topic. Every step is independently observable, every failure is preserved, and every valid order exits with a unique identity it will carry all the way to execution. In the next video, we'll follow this order into the risk service, where MiFID II pre-trade checks decide whether it ever reaches the matching engine.